have a giveaway today, thanks to Jason in the back, donated some money to the meetup. If you could RSVP if you haven't already, that would speed things up. If not, I can just take names too. That's cool. Do that now if you can. We'll get to it at the end. Cool. So yeah, my name's Jim. I work here at Aweber. I've been here for quite a while, a number of years, all over the stack. And I've been specializing in the front end since roughly 2011 or so. Building UIs has kind of been my passion, so that's where I've ended up. And tonight I'll be talking about functional programming in JavaScript. I intentionally chose the wording intro over like beginner. Just I'm not sure where everybody's at, but the topics included tonight are more on like the beginning end of functional programming. But that said, this is sort of a build-up to, I would hope, maybe a follow-up talk, either talk or I like the idea of a workshop as well. I don't have any specific ideas for a workshop. I was thinking maybe a pure script workshop, but we'll see. I'm definitely, if anybody's interested in pure script or like the more intermediate to advanced stuff, functors, monads, monoids, applicatives, that sort of stuff, I'm game. So either tweet at me or mention in the BucksCo JS Slack channel or Meetup itself, whatever. I'd be happy to do any of that, so that'd be really cool. But anyway, like that's setting a pretty high bar. I figure it'd be good to have something like this to point back to if we ever get there. So that's kind of a motivation for this talk, and to just kind of spark some interest in this stuff, since functional programming is particularly hot right now in the front end. So that's that. I do want to throw out there that I'm making pretty liberal use of VS6 in the examples. I hope that's okay, but if there are any questions about what particular syntax does, feel free to ask, and feel free to ask questions in general. I'm happy to take them. So let's jump in. So functional programming, like what are we talking about? I literally typed in what is functional programming in Google, and this is the definition I got. I'm not going to read it to you, but I've highlighted or boldened, I guess, some points on there. The main things are that we're talking about functions in sort of a more mathematical context. So, you send some inputs into a function, you always get the same result. It's a very pure sort of functional sense there. And then the second thing is to avoid side effects and mutation. And I just want to asterisk that a little bit because we're not talking about like completely avoiding it. The goal is more to like limit or control it. If you have no side effects whatsoever, you're not going to have interesting programs. So there's lots of functional programming languages out there. There's Haskell, there's the Lisps, the MLs. JavaScript isn't a functional language per se, but it does have a lot of the constructs necessary to allow one to program in a more functional style. We're going to take a look at a number of the characteristics and tools that make up the core of what functional programming is. The first of which is immutability. I'm going to try and stack these in an order that makes sense and builds up, but some of it gets a little difficult to kind of make a sequential jump. So starting with immutability, this is the idea of reducing or eliminating assignment and reassignment. Some functional languages actually don't have an assignment operator. You just can't do that. So that's something to think about. It's pretty cool. And the idea there is that variables are just inherently more complex than values. In JavaScript, you have object.freeze and object.seal, which are things you can use to make it so that you actually cannot modify an object once it's been frozen or sealed. They have their own caveats, and I just want to mention them. It's not, there's no necessity to use either of those when programming in a more functional style. And then lastly, I just want to touch on immutable data structures. So you may have heard of or are familiar with Immutable.js. There's also Mori, a few others. These libraries use a special data structure under the hood called a tree, spelled TRIE. The idea there is that instead of having all of these copies of objects, you still have the copies, but internally under the hood, they share like huge chunks of the memory. So this would be applicable if you had, say, like if you had the state of an application and you're recording that state as it changed. So let's say you have like a history of like 20 states or 100 states. You might be interested in an immutable data structure where the vast majority of those states are actually shared, and it isn't until like you try and change it that you get like a new version. But under the hood, they're all utilizing kind of the same thing, but where the differences lie is where the trees kind of diverge. And again, in day-to-day practice, like unless like that is a concern, you don't necessarily need anything like that. And I'll mention too that my one gripe with Immutable.js is that it has like a very object-oriented sort of API built on top of it. That was very intentional by Facebook. They wanted to keep it kind of like idiomatic in the JavaScript world. But I personally am not a big fan of that, and I know that there's at least one library that's being written as like a wrapper around it to give more of a functional API. But we don't have to get into that. So real quick quiz time. Just looking at variables and changing them in a JavaScript context. So if I have foo that I'm assigning to a number, I assign bar to foo, and then I modify bar. Does anybody know what happens to foo? Yeah, it stays the same. Strings, same. How about arrays? Arrays actually will modify, as will objects. That's interesting. There's a difference there where you've got your primitives versus non-primitives, and I don't want to get into it too much, but this can lead to like a lot of like difficult to track bugs. Just sort of the motivation for this whole immutability concept. So let me pull in this library called Ramda. Ramda has a function called append. You give it a value and a list, and it will essentially do what that push operation was doing before. It will return the same list with the value appended to it. But notice here that my foo is not modified.
Is this a library?
This is a library. Next slide.
Oh, okay.
So Ramda, wow, that's cool. What is this? Ramda is a utility library. It's akin to underscore Lodash. It's just a big toolkit of many functions that are of use day to day. And it's got a general philosophy. I'll just parse some bits out of that bottom paragraph. It aims to be practical. So that's kind of like goal number one. It operates on plain JavaScript objects and arrays, so you don't have to be introduced to any sort of like concepts that are coming from outside of JavaScript. There's no like linked lists or other things that might be coming from like a list background or any of that. It's just what you're used to working with. And then lastly, it champions the idea of immutable objects and side effective free functions. So Ramda's big thing is if you're modifying something, do not modify what you gave to it. Stay immutable. And yeah, so this is going to be used throughout the examples. I'll plug real quick that Ramda's got a really great community. They're like super open and super friendly as far as contribution. I personally am a contributor, and they're super active. So if you're looking for like getting into open source, Ramda's a great place to start. Cool. So next functional trait, purity. So purity in a functional programming aspect is so what is a pure function? Is a function that the output only relies on the inputs. It's deterministic, so given the same input, I will always get the same output no matter what. I can have the first two things, but if I'm doing some other thing over here, some sort of side effect, it's no longer pure. So we need to make sure that there's no side effects from calling our functions. And if you're doing the three of those things, this is referred to as being referentially transparent. That's just a fancy way of saying, given any like function call that's referentially transparent within my program. If I were to replace that call with instead the value that would have come out of calling it without modifying or breaking my program, that function is referentially transparent. And that's like a really good way of thinking about like, is this pure? Because sometimes it's kind of a gray area. It's hard to decide. Some indicators that you are impure. If your function takes no arguments, it may be impure. If it returns undefined / void, might be impure. Makes a reference to this, and if it uses globals. And again, like I want to stress that these are indicators; they're not absolutes. But chances are, if you're doing any of those four things, you're not referentially transparent. Some quick examples of impurities. Console log returns void and modifies the environment that you're running in. Math.random is impure because it's not deterministic and it takes no arguments. And array splice, so that will return whatever it deleted out of the array, and it also modifies the array in place. Again, impure. I'm going kind of quick. I actually have a lot to cover, but again, like I just want to stress, like, feel free to ask questions. So higher order functions up next. So a function is considered higher order if it does one or both of the following. If it takes a function or more than one function as an argument, or if it returns a function as the result. Quote unquote a higher order function. And so these are like the pillars of functional programming. Like if you're not doing like a functional style yet, this is where you would start. Is map, filter, and reduce. These are like the big three. So let's take a look at those. If you're not familiar, or if you are. So map is basically applying a transformation amongst. It doesn't have to be a list, but I'm just going to talk about lists today. Apply a transform function across all the values inside your list. And the shape is going to be the same. So your values may or may not change, but the shape definitely will not change. That's map. Filter is a similar idea. You're running a predicate function across all the items inside your container, I'll say. But this time, the values will not change. The shape may, depending on whether or not the values pass that result, pass the predicate function. And reduce can do anything. Typically, your intuition says that reduce will like reduce the result set down. So you might like reduce down to a sum or reduce down to a product or whatever. But that doesn't have to be the case. Reduce, it's sort of like, it's not named very well because of the fact that it doesn't always like reduce your result set down. But that's generally the intuition that you'll have. And just going off of that, I think it's really important to note that map and filter can both be implemented with reduce. So some quick map, filter, reduce examples. Again, we're only talking about lists in tonight's talk, but you can see in the top there, we're essentially mapping an increment function. So take the values, increment them by 1, return, and I want to stress that like the original data is always unmodified. They're always new copies. Filter, we're just filtering on the is even, and reduce is taking a sum. I took the liberty, in case anyone's not super familiar with reduce, of just unfolding that. So
Are these actual functions within JavaScript, or is this a special
they are, yeah.
dialect?
No, yeah. This is like ES6/ES 2015 style.
Okay.
On the left-hand side of these little rockets is the arguments, and on the right-hand side, there's an implicit return here. And so this is just returning, in that case, like mod 2, triple equals 0, etc. And yeah, so that's the sum at the bottom there. Any other questions? Okay, so another higher order function is the concept of like this unary function. So Unary is, if you're familiar with decorators at all, I like to think of it more akin to like a decorator. Unary takes a function, a variadic function, or like a function that takes multiple arguments, and returns the same function that expects a single argument. And I've actually, I don't remember what it was, but I actually needed this this past week. But down below I've got an example of why you might want Unary. It's sort of a little bit eclectic. Like, it's kind of weird. Why would I want to do that? Oh, and this is just the more concise ES6 Unary, but they do the same thing. So parse int parses an integer out of a string, but it actually takes two arguments. There's an optional second argument that is the base or the radix. So normally that defaults to 10, the base 10 number system, but you can give it whatever. And then map, array.prototype.map anyway, every time it invokes the mapping function, it actually invokes it with three arguments. The first argument is the value, the second argument is your current index, and the last argument is the array. And so what happens here, if you just map parseInt by itself, you end up with one, not a number, not a number. And if you think about it, so just think about the bases. This is base 0, which isn't anything. It just defaults back to 10. Base 1 and base 2. So 2 in base 10, that doesn't exist. 3 in base 2 doesn't exist. Or 2 in base 1, rather. So it throws like funky results. And again, that's like an easy mistake to make. But if you wrap it in Unary, now parseInt is only expecting the one parameter, and it will always use the default as the second, which is 10. So you get what you would expect. Yeah, so it's higher order functions.
Is there anything like curry?
Yeah, we'll get to that.
Okay.
So declarative API. So the idea of being declarative is more an emphasis of what you're trying to do as opposed to how to do it. And it's kind of epitomized by SQL. When you're writing like SQL queries, you're not telling the engine how to do what it's going to do. The engine knows how to do that. You describe the result set. You're describing what information you're trying to extract from your database. And that's a much more declarative way to think about it. These next two slides are really stupid. I almost pulled them out, but I thought they were kind of fun. Let me transport you all back to my 5th grade. We had an assignment where the class was divided into 2 groups, and the assignment was each group had to define this like really mundane task to someone who didn't know how to do it. So the two tasks were how to make a peanut butter and jelly sandwich and how to put on a raincoat. And think about it like you're going to explain this to like an alien or somebody who like literally just doesn't know how to do what you're describing. And the class, each group would like do the thing and then trade, and depending on how pedantic everybody was being, you may or may not like get the result. And it was really silly, but that was the idea. But I actually don't remember like what the objective was. It's kind of a weird assignment, but it at least shows that like that's like kind of hard to do. It took me a while to like write all this out, and like I'm thinking from the other side. Like if I was like trying to like really like nail this guy, like I'd end up with like an inverted sandwich, or like I don't know. It's difficult to like write it all out, and I don't know. It's kind of straw man. I don't want to like apply it to code, but like when you're thinking about like the constructs around things and like really spelling it out, it's just more error prone. There's more moving parts. It's just it's kind of awkward. And so here's
the this sort of exercise. I did this in college. It's basically to demonstrate that it's not just so simple to tell a computer make a peanut butter and jelly sandwich. You should have to tell it how to do it, and when you realize all the different parts, that puts things into perspective. So that's the whole reason for the exercise, to put things into perspective for the student.
Yeah. So yeah, making a peanut butter and jelly sandwich. My take on the declarative way to do it, ask Dad. Ask Dad to make me a peanut butter and jelly sandwich. And I don't know, I mean, maybe there's like a poltergeist in the jelly or something that doesn't turn out, but I'll probably get a peanut butter and jelly sandwich.
Couldn't you just declare a loaf of peanut butter and jelly?
Yeah, new it up.
And then eat?
Yeah. So, yeah, there's stupid slides, but declarative, imperative. Let's just take some quick examples, and again, this is kind of straw man, but whatever. So here we're doubling our result set. And above is an imperative approach that uses a for loop. Down below, our handy map. And here's a similar but different summation. Again, using kind of a more for loop construct versus our reduce. And the point is just that like there's a lot going on above. Like you've got these temporary variables. There's just inherent mutation because that's the only way to do it. With the for loop, you have to mutate it. Whereas down below, you don't need to do that. There's just a lot of like rigging and like side things going on when all you're trying to do is sum some numbers or whatever this was, doubling some numbers. So yeah, the idea is to try to keep it as declarative as possible. It's not even necessarily about keeping the code more concise. It's just about like limiting the things that you have to think about. So up next is currying. So cool. Currying. What is currying? So a curried function. So first, currying is a very close cousin to partial application. So if you're familiar at all with function.prototype.bind, it's very related to that. The idea is that if I have a curried function, say it takes 3 arguments, if I don't supply all 3, rather than the function continuing as if those were undefined, it returns a copy of that function, where the arguments that I did supply are already partially applied into that sort of copy of the same function, if that makes sense. Curried functions are typically data last. In other words, say for example I have like a get function that takes a property name and like an object, and it returns object.property name. There's 2 ways I could set that up. I could take the property name first, or I could take the object first and then the property name, which is pretty idiomatic JavaScript, I would say. I'm trying to think if underscore Lodash has that function, but that's how I kind of expected that API to look. Or you can reverse it, where the data comes last. And the point of pushing the data last, it's not even about pushing the data last, it's about pushing the things that are most likely to change toward the right. And the idea is that next bullet is that you want to be able to use currying as almost a syntactic sugar to build more like specialized functions. So for example, I might have like an add function that takes, that might even be my next thing. It is my next thing, so we'll get to it. This is very enabling for function composition, which we'll get to in the next section. So let's talk about add. So I have this add function. It's add. It takes 2 numbers and it returns the 2 numbers added together. But if I want to use this, let's say I want like add 1, like I want increment, or like I want add 3, and it would be really convenient if I could just call add 3 in parentheses and get that as a function back. But what happens? It doesn't work. You get a type error. And the reason is that in that first invocation, it assumed that 5 was undefined, it returned the result, and then I'm trying to call the result on, I don't know what that result would be, not a number. But you'd end up with it's not callable. Whatever it is, it's not callable. So you end up with a type error. We can use our ES6 syntax to get kind of close. We can now like make this nice add 3 function and just call it again with our second parameter, and it works. But now we've kind of broken the more idiomatic case. We can't just call it the way we want to call it in quote-unquote normal JavaScript way. So it's like you get half a star. Like you're kind of there, but not entirely. Luckily, Ramda supplies us with a curry feature. It actually supplies us with two. There's a curry n where you can specify the arity. That's handy if you've got like optional arguments, which is pretty typical in JavaScript APIs. But just sticking to curry for now, we'll curry it with Ramda. And now we get the best of both worlds. We can call it individually and get back our new add3 function, or we can just call it with everything and get a result. Super handy. And hopefully everybody can see the bottom there. If not, I'm just mapping over our add3 to demonstrate that I've got an add3 function mapped over 3 values to add through to them. What's up?
What's the benefit of using that new syntax?
Sorry, which one?
What's the benefit of using? Yeah.
So can you see the bottom here?
Oh, okay.
Yeah. So the idea is like, so add3 is like easy to think about. Well, I'll say this here is easy to think about only because it's so short. So and assuming you're familiar with map. So like in my head I can be like, oh yeah, I'm mapping add3 over all of these. That's cool. In the next section we talk about function composition. That can go like way out, and so you might want to say like you might want to assign that to something like var or const add1 or inc equals add1. But the idea is to just be able to create functions from existing functions to make use existing functions to make new functions that are more specified. Does that answer your question?
For brevity, ES6 makes it shorter, gives you some more syntax capabilities.
So,
Would that be correct?
yeah. In contrast, you could have an add1 function whose like only job was to add 1. You could just define that. But here, like you've got this like higher level concept of add, where like it can be anything. I can add 10. I can add 8. And like this is, I don't want to get like too like caught up on add. Like, the idea is to query like anything. Like I gave that getter example before, but if I've got the property first, I can be like, oh, I want to define getName. So I have this query function, takes a property name and an object. I now have getName, which is built from those. Like I already had those; they were in my toolkit, and now I've got this new getName that I've either like defined with like const, so it's first class, or I'm just like throwing it around. GetName, map getName over my objects, my list of objects. The idea is to be like flexible and utilitarian, I guess. Hopefully that helps. Cool. I'll jump to the next slide. So Ramda, hope this isn't getting too overwhelming, but just staying on the idea of querying. So Ramda, so I'll start out by saying that all of Ramda's functions are queried. They just all are. So it's super handy. So the one caveat is that there are cases where you could really go either way on the function order. So some great examples are divide and modulo. Ramda provides 2 mechanisms for dealing with that scenario. The first one is this special r under, and that basically acts like a placeholder. So if I stick that in a query function, once the function is expecting one last argument, it's going to put it there instead of like what normally puts it. So reciprocal works with divide just out of the box. We're dividing by 1 to kind of like flip the number. Half, on the other hand, we want to divide by 2, but we want the 2 always on the right side. we still want it curved. So like, we tell it always put the 2 over here, but I'm going to put a placeholder in the first one. And when you complete like the half, so half of 8, you give it 8 and kind of complete the calculation, it's going to stick the 8 on the left-hand side and give you back the 4, and so on. So I really like that syntax, the placeholder syntax. I think it's really easy to think about. There's another alternative, which is r.flip. And what flip does is it takes the first 2 arguments of any function and flips them. So you can see how you would achieve the same thing. But flip, you can't just flip everything. Because once you start expecting like 3 or 4 params, usually 3 are okay because it's the data that's last. Well, no, that's still not true. So like, yeah, once you've gotten into 3 or 4 params, which doesn't happen a lot, but there are functions that take that many. Flip no longer like is really a help because you're just flipping the first 2 arguments. But sometimes like I don't know, like intuitively, that might make sense to you. Like, before I knew about r.under, I would just flip things, and that worked out fine. But again, I prefer the kind of placeholder syntax. Makes sense to me intuitively. And then these are just our 3 functions. Again, reciprocal, half, and is odd. And again, we're just kind of like completing the calculation, giving it a second param, or a third, or however many params you might be expecting. Cool. So function composition. This is kind of like getting close to the end for concepts anyway. So composition is the idea of gluing all of these functions together. And so hopefully this will even get back to your question, like what's the point of all this? Like why are we doing this? This composition. So what we're doing is we're kind of building these pipelines where we're taking, we're putting a value into a function, taking the output, and then immediately passing it into another function to build this big piped transformation. It doesn't have to be big, but building this transformation of very generic, reusable, and useful functions. Traditionally, when you see compose, that's a composition that kind of runs from the right to the left. And the reason is that this is essentially what compose is doing. So if you've got measure user functions, that's how it's getting called at the end. So your parens end up here. So that's why, if you ever wonder, like, why is this running from right to left? That seems kind of backwards. That's the reason. And most libraries, Ramda included, give you the flip of that as well. It's called pipe in Ramda, and that actually runs from left to right. So what you use, it doesn't really matter. Compose, the idea of composing from right to left is very universal amongst the more like quote-unquote functional programming languages. So for that reason, I prefer compose over pipe. But you can argue that pipe is more Unixy or whatever. But anyway, so the idea is to build these kind of like point-free functions. A point-free function is a function that doesn't name its inputs, and the idea there is to just be like very generic. Maybe I started out with like a takes first 2 function. You give it an array and it returns the first 2 elements in the array. Well, that's sort of specific. What if I just didn't do that? And I give it a string. Now it returns the first 2 characters of the string. Like that's totally conceivable. But I've never like named my inputs. I'm just piping values through. Yeah, just staying very generic. And this, so if you've ever like heard anyone say, I don't like new, it's not composable, or like, I haven't heard people say about throw too often, but it's the same thing, like, it's not composable. This is why, like, you can't just have, well, without like wrapping it in a function and like calling new on a constructor, you can't just like throw a constructor in the middle there. This context will get all screwed up. So that's why in this sort of paradigm, functions are just always preferred. And as well as factories. Like if you can work with objects, you just would want to wrap it in some sort of a factory function, and then you're golden. Throw, on the other hand, is going to screw everything up. But Ramda actually includes a function for essentially wrapping throws and dealing with the errors that may ensue. As function composition, I'm going to throw a law at you. So this is an associativity law, and I think it's really important, which is why I included it. But compose is actually associative. So just to like bring you back to math class, early grades. Associativity is the idea that like it doesn't matter how your things are grouped. So like add, for example, is associative. If you're adding 3 things, it doesn't matter where you put the parens. You're always going to get the same result. In JavaScript, you have to think about order of evaluation, but it still applies. So it doesn't actually really matter because you're still like kind of going through your pipeline. But the idea here is that if you've got 3 functions that are composed, you can group it on the left, you can group it on the right. It doesn't matter. You're still going to get the same result. And this is really important. And the reason is because you can take any subcompose and pull it out into its own function and replace it with that new function. And it's like the ultimate in code reusability. As well as like the Martin Fowler idea of like red-green refactor, and like just pulling out these chunks of code, naming it, making it first class, but still like doing the same thing without changing the code. Compose is super exciting. I love Compose. And there's another law. I don't know if it's a law, but an idea of map fusion. So this is the idea that if you're composing 2 maps, that's inefficient. Like you're essentially walking your data set twice. It's actually exactly the same thing as mapping the compose of those 2 functions. And that's also really important. If you've ever heard of transducers, they're like a similar idea, except they also apply to, they apply to map, filter, and reduce. You can do all of those things while walking your data set once. But it's a little more complicated than this. It's not the same thing, but it's a related idea. But like, this is really important. Like if you've got a composition chain and you see you're doing like map, you can do it as a single map, compose those functions, and now you're only walking your data set once, but achieving the same result. It's a nice optimization. And it's something that like you might not notice normally without like having been composing everything. Once you start composing everything, then you can really like see like these are where I'm mapping. Like, this is where I'm walking my data. Like you can reorganize. And then like recompose, like here. It's really exciting. So let's look at some examples of compose, because this is getting a little high level. But I've got this handy function up here, upper name. It takes an object that has a name property and returns just that name property in uppercase. I use this all the time. And that's like the long form. But then down here, we can kind of like rearrange and do it in more of a point-free, generic manner, where your data's coming in on the right, it's getting the name property, uppercasing it, and returning the result. And there's the example, which is uppercasing Carol. And here's another example that's kind of more built up. So imagine we have some sort of fake shopping cart. And the goal is to take all of all the items in our shopping cart, whatever blobs of data they are, we're going to make them into an unordered list. So how might we compose this problem together using like small, easy to test, generic functions? So this is all kind of made up. I've defined 4 here. So get cart items just takes those items and plucks out like the records. Format item name is designed to take an individual record, takes the name, and like titleizes it, however you want to imagine titleize working. We then escape those values so they're safe to work with, and stick them inside an LI. And then we map over all of we're mapping that over our data sets. So we end up with like the data set that's now inside LIs. And we take all of that, stick it inside a UL. We've just kind of like composed all of that together. And I even made use of our double map. Like this could have been map format item name map list item, but then we're walking our data set twice. So we can instead compose those and then map it once. Does that make sense? Any questions?
So you're only navigating it once in this approach.
Yeah. And and this is stuff you could do without functional programming. You could do that. It's not hard, but the idea is to take these concepts. We've never modified our record set. Those records are completely untouched. We've only made transformed copies of the data. We're composing together. Who's to say my imperative version wouldn't have run 2 for loops to create those list items and format them and whatnot. I've been programming this way for a while, and it's been working out really nicely. So that brings us to the dream. My dream is to compose everything, and you kind of can. And some of that gets into the more intermediate to advanced stuff. How do you compose async functions? We'll actually kind of get into that, but not in an in-depth way. But yeah, I'm really excited about Compose because of the fact that it's got so much potential for code reuse. When you're composing everything, you see what you're doing, you see where you're repeating, and you can pull that out and have just really nice functions.
You can compose promises, can't you?
Sort of.
Sort of.
They're not. Sort of. Yeah. And actually, Ramda has a compose P, which is that. It's composing promises. I found it a little clunky to work with, and when we get to the code, I'll circle back to that. And then pushing all the side effects to the edge of the application. Again, the idea is to keep the meat of your code as pure as possible, and where you're making those side effects, because you're going to have to dump them out. Put them in the bootstrap, put them out in the environment. Try your hardest in that to work with those. So what are some caveats? I can't just be telling you this is all rainbows and everything. There has to be some downsides, and there are. Documenting curried/point-free functions gets awkward. If you're just working in a JS doc sense, think about that. You've got a function that returns a function that returns a function that returns a value. What? How do I document that? And it's really hard, especially if you do it to the spec. To the spec is really silly. I won't even get into it, but you have to make sub JS docs for each of those functions. It's really silly. But there's a concept called of type signatures that you'll see in the functional languages, and the Ramda docs are more akin to that. And the idea of a type signature, well, I'll get back to the type signatures because I have a little bit of those in the code examples, but the idea is that you kind of separate out each of those arguments with an arrow. I won't even get into it, but there is a solution if you're looking for it. It takes a little while to grok it. They're definitely not something you just can look at and be oh, I know what that function does. But once you get it, it's a little more intuitive. So forgetting to apply the final argument to the curried functions, I do this more than I'd like to admit. Luckily, the tests usually catch that, but not always. But the hardest part is when you're writing a predicate function or you're expecting the result to be true, false, and you forget to actually pass that last argument. It returns a function, and you're relying on JavaScript to kind of coerce that. It's oh, why is it returning true for everything? That's not right. It's really just returning the function because I never supplied the last argument. So that's kind of just a thing you have to be mindful of. There's no real great solution to that. The solution in Haskell is that it wouldn't compile. That's a strongly typed language, so you actually have to spell out your types, and the compiler would help you. It would be you didn't do this, but you don't get that from JavaScript. Debugging can be a little awkward if you just imagine these big pipelines of data transformations. Well, how do I get in there? How do I console log? How do I run debugger? And the answer is there's a Ramda function called tap. Tap takes a function, and what it does is it essentially it passes through. So like you give the, all right, so tap takes a function, it will return a new function that's like a pass through. So your pipeline doesn't break. It gets its value, sends another value out unchanged, but it allows you to perform a side effect. So you can, for example, say r.tap console.log, and it will log the value. Or you can tap, give it a function that calls debugger, and then it just like stops execution right at that point. So those are super handy. I use those a lot. And that's kind of the solution when you're like, you just got like this big pipeline program that doesn't have any stopping points. It's just always kind of flowing through. Tap. And then lastly, code structure / organization. This one is like kind of like wishy-washy, but the point is that you end up with a lot of functions, a lot. So what's been working for us is to have, you can name it whatever you want. We've got like focused utility libraries. So like normally util is like a smell. You just got all these functions that do whatever. So we try to at least keep them focused. There might be like a date util, or we do React, so we have like a state util that every function inside state, or yeah, every function inside the state util takes state as an argument and it returns something. So that's probably my best recommendation now, but it has been a pain point. Like I've got 200 functions, and where do these go? We've just been sticking them in like util libs that are focused. Cool. So I promised a React app. I have one. I don't know if it's going to be great to look at because it's very small. Like I wanted to keep it small, but maybe it's too small. But whatever, we'll work with it. So we'll jump over real quick, and I'm running close on time, so I don't know if I'm going to show too much of it. But here's the idea. So all right. So
We used to edit.
I use Vim.
Yeah, okay. Right now, using the Eclipse doesn't seem to like ECMA6.
Yeah, there might be a plugin for it. I don't know. Anyway, so real quick, so this is a nice blog article that I refer to from time to time. Choosing HTTP status code. Like if you're working on an API, you're like, oh, what should it return in this scenario? Like this blog post has actually like it's a little bit joking, but the suggestions are also actually really good. But it's just a decision tree on like which response code to return, and they're all color coded. So the green or the yellow results are considered standard, green are useful, and purple are irrelevant. So I was taking this concept, but I wanted to make it more interactive. So that's what I did. This up. It's like compiling the ES6, don't worry about that. The color's a little silly, but this is the idea. So like, is there a problem with the request? No. Is it server side? Yes. Should we retry? No. Is there a problem with the server? Yes. Is the server responding? Let's say no. And 504. So that's the idea. And there's only two actions. It's what is my like answer to the current question and start over. Those are the two actions. I don't know if I even have a time for a quick crash course on React. Does anybody so like unfamiliar with React that would help? I'll at least show what my state looks like. Is this big enough? Oh man, can you increase?
You can zoom that, yeah.
Yes, that's too much. So the state's really small. Decisions are like the decisions I've made up to this point. That's just an array. So these were the decisions I just showed. The tree is that entire decision tree, all like laid out. I won't dig too deep into that, but like the whole thing is in an object. And S is just the strings. So I can translate those in like a more approachable way because they're all like encoded in here. So that's the state. Is there anything anybody like wants to look at? as far as that, I'll show the bootstrap real quick. Is that big enough? Make it a little bigger. So this is like the bootstrapping code. This is like the main entry point. And this is literally, again, it's like a really small application. It's not real world at all. But this is literally all of the side effects is this. Everything else in the application is pure, which is really cool. And all this is doing, this is an impure call. We get app out of the DOM, or like that element out of the DOM. This is like a component, a React component. It's providing our store, but I won't get into that too much. And then we're creating the store. That is pure, but we're wrapping inside the tap that I was talking about to just assign this whole thing to window.app. And then, yeah, that all becomes a React component, and we render this inside that element. And that's it. And then, like, this is why I get excited about virtual DOM. It's not even like React. I like React because it's got the community behind it. It's like vastly bigger than like any of its any of like the virtual DOM libraries. But the other libraries are great. Like, I would totally use them. It's just the fact that React is so prominent, has such a big community. But the reason I get so excited about it is because the declarative API. Like, I don't have to think about updating the DOM. I just say in a declarative way, like, under these circumstances, I want this to have this class name, and React does all of that. But inside my application code, like, all of that is pure. Like, I'm just working with these little factories. So that's that. I'll show the actions real quick. Actually, no, this isn't even really using that stuff. But the actions are all, they're meant to be like serializable. So the whole idea behind this stack is that you start out with an initial state. Let me get to reducers. You start out with this initial state, and you're applying actions over time. So you can think of that as like a reduce operation. If I've got this initial state, this list of actions, reduce over that, give me the result. The result is the current application state. That's the idea. And then here's where I'm using all of the stuff that I've been talking about. Again, there's not a lot to look at because there's only two actions. So the way the reducers work is it's a one-to-one generally. So my two actions are start over, which is here, and push decision, which is here. And they're just doing those things. I won't get into the code too much, but with start over, I'm just like zeroing out the decisions array. If you squint a little, you can kind of tell, but I don't know why I did this, but I used a concept called lenses. So lenses, which you can see here, they give you like a narrow view into a big object. And so with a lens, I'm peering into the state, but I'm only peering into the decisions. And then I'm operating over that to set decisions to an empty list. But because it's a lens, it updates that little property, but I get the whole thing back. That's the 20-second overview of lenses, but they're super powerful and very relevant to like this style of programming where you've got a giant state tree, but like any given action is probably only going to be like zeroing in on like little pieces of that tree. There's all this is on GitHub, by the way. There'll be links at the end, so don't get too caught up on things. I started out modeling this with like an actual tree, like a tree data structure, and I ended up getting caught up somewhere in here. I got caught up while I was spinning my wheels trying to fold two trees together. So I'll show you how the actual decisions are modeled. It's a giant array, an array of arrays, and I got caught up trying to take my existing like big tree, turn an array into a tree, and then fold that in. So I was like, all right, screw it. I didn't feel like spinning my wheels on that. So this is like completely unused tree, but I left it in case it's interesting. It's a more like, it's not an object-oriented tree. It's a much more functional tree. The nodes always return new nodes. Yeah. All right, so we've got 5 minutes left. Is there anything anybody like wants to look at in this? Because I've got more code.
I have a question.
Yeah.
So Have you noticed any of the negative effects of using Ramda, like performance-wise? Does it matter, or what made you choose that over Lodash FP?
That's a great question. So I actually don't know if this is still the case, but I know JDD, John David Dalton, the author of Lodash, has always held strict equality higher than value equality, and I'm of the mindset that value equality trumps in a functional style. So like, there's no doubt that like running like triple equals, like strict equal, in like all the equality checks is going to be more performant. But I've personally not found any issues. That said, like I'm never working with like giant data sets. If you're working with like giant data sets, that might make a difference.
So the use of the query functions everywhere, you don't find doesn't even have any blips as far as
no, I mean that wouldn't even be like the curried functions. That's like, I don't think that would ever be a bottleneck. I mean, at a theoretical level, sure, but I don't think in practice. But yeah, like when you're doing equality stuff in like xprod, where you're like taking a cross product of like big sets, and like maybe Lodash FP is doing value checking now, but at least the last time I looked at it, it was doing strict equality, which I didn't agree with. But yeah, that's a really good question. Any other questions before I jump over? Yeah.
So this seems kind of academic. I wonder if there's an actual like pragmatic benefit to using this paradigm specifically in the context of what you actually work on a day-to-day basis, or is it mostly just stylistic, or what do you get from it?
I feel like I'd be a little jaded if I answer that, but for me anyway, I mean, I'm really pretty passionate about functional, but I do find, well, I don't know how to answer this unbiased, but for me testing is okay. So I related this to you. I had a scenario recently where I wasn't even bringing up my application because I was so confident with the code just based on the tests that I literally hadn't even been bringing it up, and I saw somebody working on it. I was like, wow, like, it was unstyled previously the last time I looked at it. I was like, wow, this is really coming along. Like I honestly thought it was a screenshot of the comps. I was like, wow, is this the application? I literally hadn't been bringing it up. Like I was just like working in like the state and like modifying state, and like I wasn't even concerned about that other stuff. I knew it would work. But yeah, it's highly testable. For me anyway, I can really wrap my head around this stuff. I've already mentioned the code reuse, being able to extract all of these subcomposes out and come up with new functions that reveal themselves to be actually used like all throughout the code.
Do you have test code? Like what the tests look like? Does the composability mean that you can write fewer tests because they're composed from?
The tests,
or are you splicing everything into such tiny functions that you actually end up with more tests?
More tests. So not everything ends up being exported. So like that export keyword, without that, I wouldn't even be able to get to decision tree or decision to tree. There are things that like we test at a higher level, but then like in the code we're like, oh, like this might make sense to break out, but like I'm testing it through something else, if that makes sense. So I mean, I don't know, like, and as for the tests themselves,
Oh, so you end up with a larger definition of what a unit is in your code, I guess, from that perspective.
If we do that, we don't always. Usually the units become smaller.
Yeah, I think smaller.
Huh.
I can just say from an outsider, I agree with the testing piece. Like if you have compose and you have your small functions,
right.
When you're testing those small functions, you don't have to test compose. Compose is already tested.
Yeah.
And the combination of them, you don't test again because that's just overlapping tests. So you end up testing less, and the tests become so much simpler to write since they're pure.
Yeah, and that's certainly one of the goals. But I won't argue with you that it is also very academic. I tend to agree with that. Any other questions? We're like at 8. I hope nobody has a hard stop. we've got a giveaway. Did I mention? Yeah, we've got a giveaway. Let me just jump back. Giveaway time.
It looks like you can't RSVP after like the start time of the
Oh,
event.
That's okay.
Just so you know.
It's okay. So this had more code to go with it. I don't know if we'll be able to look at it just based on the time, unless like everybody's like, cool, let's do it. But here's the objective. So I wanted to build a deterministic random number generator. So always returns, yes, the pseudo random number generator. So it always returns the same output given an input, given a seed value. Then we decide on some entropy source, maybe it's a birthday or whatever, it doesn't matter. Grab the RSVPs via the Meetup API, and we'll just splice in names or like exclude names if we need to. Then use the random number generator that we coded to choose the winner. My original plan was to live code all that, and I practiced it, and it took me like 45 minutes, so I know we're not doing that. So anyway, I'll at least like skim over the code, and again, like all this will be available or is available on GitHub. I'll send links if anybody wants it. So real quick, you know what? Let me just look at the program. Okay, so these are the names. I'll just run it again. So these are the names. Do I have to add anybody real quick? Or if you want to be excluded, that's cool too. It's a coffee mug. It's a Ramda coffee mug. It's actually really nice. But if you're like, no, I don't want a Ramda coffee mug, that's cool. I don't care. Just shout out a name if you want me to add it. I've already excluded a number of us, but all right, cool. We're good to go with it. All right, so if everybody's got those objectives in their head, so all right, we'll just talk about those async composes. So this is actually using a library called task. I might refer to it as future because it used to be called future. Then they renamed it. But tasks, futures, they're the same thing. And I've got a brain dump on this library in GitHub too. If I link to it, I did link to it. So if you want the brain dump, it's that link there. And that just compares them with promises and like how to work with both. But anyway, so this is it's actually a monad. I'll just throw that out there. And so here's the idea. You're making these async calls. That's a side effect. It's impure. Can't do that. Well, we can do that if we wrap it in a function. And the way task works is you kind of wrap like those dirty details inside the function, and it never gets run. It's like a little dirty bomb, and you pass it along. You can make transformations on that future value, and then at the very end, at the end of your program, you call it. Just one comment that's it's a little. Oh no, you can't see it. Hold this up. At the very end, you call fork on it, and that's when it executes. And so it took me a while to like think about that. Like, why can't I just like .then and like do my things? Like, why hasn't this even done anything yet? But it's really nice, and I've grown to really like futures/tasks. So that's the idea. So we're using that to just grab the Meetup API, and let me just show what that record looks like real quick. Oops. That's it. So these are the responses that come back. It's like a giant object, and it's got like the main things off of these objects have like this structure. The part that I care about is the response. So response no, and numbers name. So response no, it's on the top level of each record, and member name is like a little 2 levels deep. So let's just like fly right through this. So this is a little function that just checks to see if they RSVP'd yes. It takes in a record, gets the response, evaluates it against yes. And it's a true thief, returns boolean. And here's the type signatures that I was talking about. It's like a little bit made up, but just imagine it goes from RSVP to a boolean, RSVP to a boolean, RSVP to a string. And RSVP there is the argument. These would all be like considered arguments coming through. Is the name excluded, not excluded? Get the name. Here's like kind of where the program starts to come together. So this takes the object of RSVPs. It's not an array, it's an object of RSVPs. So we pluck the values out of that, which are like the things that we're interested in. We filter by both, did they RSVP? Yes, and are they not excluded? So not excluded, are they included? And over that, we map the get name. So that's going to return us all of the names of people who responded yes. And then lastly, get names for giveaway. This is actually an impure function. Well, I don't know. I'd have to look a little closer, but this is going to end up getting. It puts all the pieces together. It takes the include and concatenates it with everything else. So that's that bit. And I already just demoed all of the names. So here's the names. That's like program 1 or whatever. The next bit's the RNG. I really hope that it's okay. I'm going over here. So this is like a super simple RNG pseudo-random. And it's based on this blog article, so if you think this is cool and you want to check it out, that's the article that I based it on. Fair warning, it's Haskell, but it's readable, it's not bad. The code's very minimal code, and he does a really good job explaining it. But the idea is that we're taking our value, multiplying by 7, which is a prime number, it's important, and then taking the mod of 101. And what that's going to do is it's going to return a random number between 1 and 100, but it's deterministic. That's the important part. Is that bit is deterministic. So ignore the fact that it's called random. It's not random. And then we wrap that in our like make RNG. So that takes our seed value, and it kind of like keeps this inside the closure. And every time we call it, we're updating the state, like returning the value, but then like updating it so the next time you call it, it returns the next value. And I can keep going, but like, so that returns 0 to 1 to mimic math random. And then our lottery here takes that 0 to 1 value and your list of names, and it scales it out. So like if you've got like 0.5 or whatever, and 29 results, it might return like 15. I don't know if that's true, but be close to that. And we just make the RNG. So I had a hunch. My hunch was that since this is like not a random, not a very like, people spend a lot of time working on random number generators. I was like, well, this is going to be crappy. Like, it's cool to like look at academically, but like at the end of the day, we're just going to want to run this with math.random so that like the results aren't skewed. So that was the intuition I had. It turned out to be completely wrong. So check this out. So I'm going to modify the program to return. Here we're interested in the distribution. I thought I put it in the comment. Oh, yes, this is supposed to be a comment. Right, so save. So this is like 2-column layout. On the left here is the number of times that the number on the right occurred. So we've got 23 people in contention. And you can see every time it ran through, it either chose an individual 4 times or it chose them 5 times, which is pretty even distribution. Like I was expecting it to be like way like not the same at all. So that's like the stupid RNG. If we swap this in with math.random, so I just want to show real quick. So we're taking our RNG, scaling it up to 23. I'm sorry. So I actually have that statically defined as 23, but whatever it is, 29, doesn't matter. And then we're calling, so r.times takes a function, which runs it x times. So in this case, 100. I'm running it 100 times. So let's just do the same thing, but we'll call math.random instead of our made-up thing. Clear. And so firstly, like, this is like, the first one was deterministic, so I'll always get those same values because I haven't changed the seed. This isn't, and like one time I've seen them go up to like 11. Here's a 10. It's all over the place. So I was going to leave it up to the crowd as to whether we want to use my RNG versus math.random. And again, arguably it's random no matter what, but I don't know. I feel like I'd have less of a chance. And maybe that's like, maybe that's some sort of bias, but I don't know. I wouldn't want to use math.random if I was in contention. So I thought that was really interesting. That wasn't what I was expecting. My intuition was telling me the opposite, but that's cool. So, all right, so that's the first question. Should we use math.random or RNG?
Use yours.
Yeah.
Yes. Okay, and what, I need a seed. Does anybody want to like, give a birthday, just a number, it doesn't,
42.
42?
Yeah.
All right, so uncomment the program. Okay, so real quick, I'll just talk about lift since maybe somebody will want to look at this code and go, what's lift? Going back to our monad, think about monads as like, do what Mitch said and try to explain a monad, but picture you've got this value inside of a container. In the case of arrays, you've got these values inside of a container. So I have a generic add function, add 1. I can't just add 1 to an array. I'm going to get it's going to throw an error. That doesn't work. But what I can do is I can map over it, and then I've applied add 1 to every value inside my container. In this case, my container is an array. That is referred to as lifting. You're lifting the function into a context. And that's like the whole idea is that you have these generic functions that don't care about the data themselves. I mean, they do to an extent, but it doesn't matter. It doesn't matter like what you have it inside. You lift these functions into the right context, and it's kind of like the functional programming equivalent of polymorphism. You've got just these reusable functions. You don't have to write the same function to work on a future, to work on an array, to work on whatever. You've got the same function, and you just lift it into a context. So that's lift. Here we're lifting the lottery function into a future context. So we've got two futures. We're making rand a future here so that it's compatible with our other future. And then we're just going to take our list, produce a random number that's an index of that list, walk it up, and that's the winner. That's it. Should we do it?
Let's do it.
All right, check this out. Stephanie, I don't think Stephanie's here. Oh, man.
Reroll.
So with that seed, it'll always return Stephanie,
So
right?
it works.
Oh, you're right. You're right, yes. We need a new seed.
1, 2, 3, 4, 5.
A5.
Cool. Yeah.
4. All right. Check it out. David. Yes.
Hey, all right.
All right.
I think yeah.
Are there any questions? We're a little over, but I'm game.
So could you go back to the compose with the that actually waits for the response? Does it know to do that? The async response?
So that's actually what's going on here. Like nothing's happened until we fork. Imagine task.of. We're going to talk about promises. Task.of is like really similar to promise.resolve. You're taking a value and you're putting it instead of a promise context where it's like we're saying this value is a resolved promise. It's like the exact same thing. This random number is like a resolved random number.
So how about when you did the request from Meetup API?
Yeah, so lift is going to wait until all of those. This is like parallel execution. In this case, since the first value is already resolved, like it's resolved, but like it's now waiting for that second one to resolve, and when it does, it's going to all converge on lottery. And yeah, if you look at lottery on the left-hand side, it's taking decimal is like a random 0 to 1 value. Values is the list of names.
Could you scroll up just a bit in the program?
Yeah. Before.
Actually, all the way. To see. So right there, the get RSVPs. That doesn't have a lift though, right?
No, the only place where we lift is at the bottom.
And we'll let that. The get RSVPs. Could you scroll all the way up to the top? That's the very first function, right?
Yes.
Okay, so this just doesn't. It returns a promise, and then okay, I got you.
And so task is like, it's really similar to like creating a new promise. I'll just note that resolve and reject are flipped. With the promise API, they're the other way. But we have like these resolve and reject functions, and when the promise resolves, we're kind of just like saying, no, I want a task instead, I don't want a promise. If that makes sense.
Yep.
Any other questions? So again, like, I'd be totally game for like step 2 or a workshop. I don't have like specific ideas for a workshop. Maybe PureScript, but so the one caveat with PureScript is that it's a Haskell dialect, and in order to do anything in it, you need to know monads. I mean, you don't need to know them, but you will be using them.
What's the dialect with Haskell?
PureScript,
Oh, okay.
it compiles to JavaScript. It's like a JavaScript alternative, but you're essentially writing Haskell, but it's strongly typed. You end up with JavaScript on the other end, but it's very cool. And if you're interested in PureScript at all, there's a great book. I think it's only $10, but it's on what's that? You can get it for free, and it's free to read online. But it's from the author of PureScript. He wrote a book. It's like 13 chapters. It's really good, and you don't even need to know like Haskell to get into it. Like it's very approachable. But yeah. Oh, links. So this thing's so tiny. Oops. I don't know where my thing went. So this is my GitHub GMF, and it's just the very first one, intro to FP talk. Links to slides are here. I've got the links to everything that I've talked about, at least can be accessed through here. But yeah, if you're interested in any of that. This specifically is the code we were just looking at, the giveaway code. If you want to look at the React code, it's linked to somewhere in here. It's right here. GMF/intro FP JS talk, all hyphenated.
Probably easier to go to GMF and click on your first read.
Oh yeah. Just it's the top one. I don't know if any of you are in the BucksCo JS Slack channel, but I'll just post it there.
But you should.
Were there any other questions? Cool. Yeah, I get pretty excited about this stuff, but that's it. So I guess we're heading over to Blue Dog, some of us. If you don't know, well,